Hello and welcome to T Academy. In today's lecture, we'll be finding the average output of half-wave rectified signal using Fourier analysis. So in my previous lecture, we simulated the circuit of a half-wave rectifier in LTSpice and we got the following plot. So the peak value here, V peak, is equal to square root 2 times 230 volts. And we are interested in finding out what is the average output V average of this signal. So in order to apply Fourier analysis, I will arbitrarily choose the midpoint of this rectified signal as my reference. So this will be 0 and these 2 points will be t by 4 and minus t by 4, and this point midway between these 2 points will be t by 2 and minus t by 2 respectively. Since you know that in order to apply Fourier series analysis, we only need to integrate over one period, and this I have chosen as one period from minus t by 2 to t by 2. Now in between minus t by 4 and t by 4, this signal is that of a cosine, and a cosine signal is even, that is f of t is equal to minus f of t. So I already know for Fourier analysis I only need to find out a n's and a naught. The b n's for this signal will be 0. And here in this lecture we'll be finding a naught, which is the average value of the signal. So f of t can be described as a piecewise function, that it is 0 in between minus t by 2 and minus t by 4, as well as between t by 4 and t by 2, while it is equal to Vm times cosine of omega t between minus t by 4 and t by 4. Now as you know, the average value a naught can be found out by the formula 1 by t integral minus t by 2 to t by 2 f of t dt. And since our signal only exists between minus t by 4 and t by 4, I can plug in the limits as minus t by 4 and t by 4 and put the value of Vm cosine omega t here. Vm cosine of omega t dt. Now I am substituting 2 pi by omega for t. So outside I'll have omega over 2 pi times, and I'll also take Vm outside. So the integral of cosine omega t will be sine omega t over omega under the limits minus t by 4 to t by 4. So this omega cancels out and I'm left with Vm by 2 pi, and inside if I plug in the limits I'll get sine of omega t by 4 minus sine of minus omega t by 4. Since we know that sine of minus theta is equal to minus sine theta, this would become plus sine of omega t by 4, and I can sum these up to get Vm by 2 pi times 2 times sine of, and again I'll put omega t is equal to 2 pi, so inside I'll have sine of pi by 2. So this 2 cancels, and sine pi by 2 is equal to 1. So the average value that I get is equal to Vm over pi. And this for our case, where Vm, the peak value, is equal to 320. So the average value will be 320 divided by pi, which is almost equal to 100 volts. So let's go to LTSpice and check if indeed this average value is equal to 100 volts or not. I'm back in LTSpice and I have the output signal open. So in order to find out the average value of the output voltage, I'll place my cursor at this V out, press Ctrl and left click, and this will open up this pane where I can see the average voltage as 101 volts. So it is equal to Vm divided by pi, as we found out in our analysis. So that's it for today's lecture. In the next lecture, we'll try to find out the RMS output voltage, again through Fourier analysis. So stay tuned to the channel, and I'll see you in another lecture.